Let's graph the following sinusoidal equation. Y equals 3 sine, bracket 1/4, small bracket, x minus 60 degrees, close bracket, minus 1. Let's look at the transformations first before we attempt to graph. The amplitude is 3. A vertical stretch by a factor of 3 has occurred. To find the period, what you need to do is take 360 degrees divided by 1/4, and that means that the period is now 1440 degrees. It means that a horizontal stretch by a factor of 4 has taken place, like so. And the minus 60 indicates that you've gone 60 degrees shifted horizontally to your right. And the last transformation is a vertical displacement of down 1 unit. So, in order to plot our 5 key critical points as they've been transformed by these 4 influencing factors, let's keep in mind the original table of values for the sine function. Remember, the sine function starts at 0, 0. And then you see the point 90, 1, 180, 0, 270, -1, and 360, 0. However, the 4 transforming factors will transform those 5 key critical points as follows. Now, to understand that, it helps if you keep this little idea on top of your table of values, and it will help you map out the x and y values accordingly. So what we did was take the original x values, and you first multiply them by a factor of 4, and then you add 60. So when you take 0 times 4 plus 60, you should get 60. And when you take 0 times 3 minus 1, you get -1. That's easy enough. So what about the second point? 90 times 4 plus 60 is 420. And then 1 times 3 is 3. 3 minus 1, which is 2. Easy enough. The third point, again, take 180 times 4 plus 60, and you get 780. 0 times 3 minus 1, again, is -1. And then let's look at the fourth point. 270 times 4 plus 60, you get 1140. And then to find the y value, go 3 times -1 minus 1, which is -4. And for the fifth point, we've got 360 times 4 plus 60, which is 1500. And the y value is just simply 3 times 0 minus 1, which is -1. Keep in mind that from 60 degrees to 1500, we have 1440 degrees that have taken place. And if you notice astutely, from here to here, you have 4 cycles. Sorry, not 4 cycles. You have 360 degrees per quarter. So from 60 to 420, this is the first quarter. So 360 degrees have taken place. For the second quarter, you might think of 420 to 780. Again, 360 degrees. For the third quarter, you have 780 and 1140, which is 360 degrees. And the last quarter is 1140 to 1500, which is 360 degrees. So you might want to think of 1, 2, 3, and 4 as the horizontal stretch by a factor of 4. And how did we know? Well, 360 degrees is the original period, but we've stretched it by 4 times, so 1, 2, 3, and 4, if that helps you visualize a little bit better. Now let's look at the graph. So here's our graph, and we have a proper scale and x and y scales. So let's plot the first point based on our graph and table of values. It should say 60 degrees, -1, plotted right here. The second point is 420 degrees, 2. So 420 degrees, 2 up here. The third point is 780 degrees, so 720 is here. 60 over is here. 780, -1, plotted here. The fourth point, all the way in the bottom, so it is 1140, -4, plotted down here. And the fifth point is 1500 comma -1, so right here at the end of our scale. So now that you have these 5 key critical points of the transformed function, now let's draw a nice smooth curve through all of these 5 points, and your graph should look something like this. So everything is connected properly.